All right, so we're taking a look at equations like this where we've got the variable stuck in the exponent. Kind of tough to get that out, but we did learn in another learning target that I've got a way to do that now. So just as a refresher, we're going to take log base 11 of 121 and set that equal to x. And you know, we didn't even almost need to convert it into logarithmic form because I know that 11 to the second power equals x. So I could have right away, if I wanted, just said that I know that x equals 2. And even if I did turn it into logarithmic form, what we're going to be doing today is just looking at some of these basic logarithms where the variable is pretty simply an answer that I can tell just by looking at it, because we have that set of numbers and their exponents and their results that I told you to memorize that would be good for you to memorize. And it looks like this one, you know, value 2, just as a refresher to remind you that a logarithm, remember, whenever you see this, whenever you see log base something of something else, that just represents an exponent, okay? And in this case, the exponent is 2. So really, this logarithm is asking the question, what do I raise 11 to get 121? And the answer is 2. So today what we're going to be doing is looking at learning target 8, which is I can simplify basic logarithms by hand using a calculator, logarithms that involve rational exponents, and also using one of two special forms. Just as a side note, that this one using a calculator is probably best seen in the video that describes learning target 9, which is change of base formula. In class we did things a little bit different, you know, like learning target 8 sort of led to number 9, and I got the videos, like the order mixed up here just because of the time that I had to make them. But anyway, go to learning target 9 video if you want to figure out how to use a calculator to simplify basic logs. So let's take a look at how to simplify a basic log by hand. For example, I've got this logarithm, log base 4 of 16. And just remember the question that it's asking. You got to kind of understand that this is just notation, shorthand notation, so that we don't have to keep writing over and over again, what do I raise 4 to get 16, right? I mean, math is all about that, taking these questions or these statements and simplifying them down to a more condensed notation so that everyone can kind of understand what it means and it doesn't take up a lot of space. So when I see log base 4 of 16, it's asking, what do I raise 4 to get 16? And the answer here, if you remember, is just 2. So without a whole lot of fanfare, I can just say log base 4 of 16 is 2. No big deal. Okay. And here's another one, log base 381. So you can do that really quick if you like, and hit pause if you want to calculate that out or figure it out by hand. But just remember, it's asking that question, what do I raise 3 to get 81? And that should be part of that knowledge base that we have about exponents and their values, like at least the numbers 2, 3, 4, 5 raised to like up to like the third or fourth power. And the answer here is it would be 3 to the fourth power is 81. So that's not too bad, right? Just something that we can look at maybe pretty quick and understand that that is something that we know. Now, if we saw something that looked like this, like log base 15 of 373.9, well, that I don't know. Okay, that's not part of my little knowledge base. So now that I would definitely want to use a calculator. And just depending on the calculator you have, remember in class this sort of led us to the change of base formula, which would have been log 373.9 divided by log 15. And that way you can calculate this out using a calculator that only has a log button that calculates in base 10. Okay, we've got the Inspire that would tell me that log base 15 of 373.9, that was my value, right? See how old I am? I was just on the screen. I already forgot what I put down. So hit enter, and it looks like that exponent's 2.18755, probably a lot more exponent or digits than that, but I have it set to like floating of 5 decimal places. So now that means that if I took 15 and raised it to that power, 2.18755, then I get 373.9 or thereabouts. And I know that it's kind of adding on this 0 and the 3 there, and that's because this digit right here, or this digit, this answer that only goes out to 5 digits is definitely rounding something. There's probably a lot more digits than that that would be employed in the answer. So keep in mind that there are some that you should be able to get just by looking at them or basically asking yourself that question. Those are going to be big on a lot of the standardized tests, because on the standardized test, if you can't use a calculator, you know that they're not going to give you a logarithm like this one, because that's really kind of a crazy logarithm. They'll give you ones that are more along these lines, ones that they know that you might already know the answer to, and they're just testing to see that you know that notation. Okay, so here's another one, log base 64 of 4. And this would be one that we definitely haven't seen before, right? And it almost doesn't make a whole lot of sense, because it's saying, what do I raise 64 to get 4? And that's kind of a weird one. I mean, 64 to the first power is already 64, so I can't really think of a number that I would raise 64 to get 4. So let's give this a shot in the calculator, see what we get. I'll clear out the scratch pad, and we'll go log base 64 of 4, and I get 0.333333 repeating for and that looks to me like it's probably the calculator's way of telling me 1/3. And I don't have the settings here set to give me an exact answer. I have it set to decimal, so that's why the calculator's not saying 1/3. But I bet you it's 1/3 here. So let's go back and figure out why that is, why it would be 1/3. Okay, so log base 64 of 4 is 1/3. And let's see if that makes sense. 64 to the 1/3 power is 4. Now, if you remember from about a chapter ago, if I raise something to a rational exponent, where it's a fraction like 1/3, it usually represents some sort of a root or a radical. And in this case, it's the cube root of 64 equals 4. And yeah, that makes sense, because this question right here is basically saying, what do I raise to the 3rd power to get 64? And that's 4. So yeah, 1/3 would be my answer. And you know what, that's not too bad. I mean, I guess that we know some of those cube roots and square roots by heart, but I've got, I think, an easier way to get this done.